Okay, so let's see what the question asks. Given the gradient, determine whether it is conservative or not. If so, find the potential function. So we're given a vector gradient here, which is denoted by big F. Hold on a second. It's denoted by big F. F of x, y, z is equal to the I component, 3x squared y z squared plus 72xy squared minus 3. And then we have the I component plus, this is the j component, x cubed z squared plus 72x squared y plus 21 z squared. And then we have the k component, 2x cubed yz plus 42xy. Okay, so we're given three components here. Last time we did one with two components. So let's first we'll find out if it's conservative. So find out if it's conservative. This is the solution. Let's do it in blue. So conservative. So in order to do that, we're gonna, let's say, let this one be p. Let p equal to 3x squared y z squared plus 72 xy squared minus 3. Q is going to be equal to this component, the j one, is equal to x cubed z squared plus 72, right? X squared y plus 21z squared. And then we're going to let r equal to the k component, 2x cubed yz plus 42zy. Okay, so now we're going to have to take the derivative of p. So the derivative of p with respect to y, and that will be, okay, this with respect to y. So we're going to take the derivative of this with respect to y. All right. So that will be, let's see, 3x squared. Okay, right here it's going to be 3x squared. The y goes away. Z squared plus, let's see, 72 times 2. What would that be? You use the power rule here. That would be 144. Because 144, oops, yeah, 144 xy, 3 is a constant, so that just turns to 0. Okay, so the derivative of the component p with respect to y is 3x squared z squared plus 144x y minus 3. Okay, that looks good. And let's see if this is equal to the, hold on a second, it's bothering me. Let's see if that's equal to the q component, the derivative of the q component, delta q, or whatever, I mean, yeah, that thing, the derivative of the q component with respect to x. So this one, we're going to derive it, well, we're going to take the derivative with respect to x. Okay, so let's do it. That will be 3x squared z squared. When you take the derivative of this part with respect to x, plus, right here, let's take it with respect to x. Oops, whatever. So that will be, okay, this component, that'll be 144 again with the power rule. xy, and then this goes to 0 because it has no x, so it's a constant, so it goes to 0. So look at these two. Are they equal? Sorry about that. So are these equal? And they are. Yes. Okay, so now we move on to the other component. So now we take now we take the derivative of the p component with respect to z, right? So this one we're going to the derivative of the p component with respect to z, we're going to derive the p component with respect to z, so that will be, let's see. Okay, so that's going to be 6x squared yz plus, let's see if, okay, we have no z here, right? Doesn't look like it, so whatever, 0. Now we're going to take the derivative of r with respect to x. Because we just did the derivative of p with respect to z, now we're going to take the derivative of r with respect to x. Let's see. Okay, that will be 6x squared yz, right? Yz plus, okay, so there's no x in this part, so that's just going to go to 0. And let's see if they're equal. Are these two equal? Yeah, they look like it, so they're equal. Now the last component, the last derivative. So we're going to take the derivative of q with respect to z, and you guessed it, the other one is going to be the derivative of z with respect to y. Okay, so let's take the derivative of q with respect to z. And that's going to be, okay, 2x cubed z. Okay, there's no z here, so we're not going to have anything there. There's no z here, and there is a z here, so let's see, plus 21 times 2, that's 42. 42 z. Okay, would this equal to the derivative of r with respect to y? Let's see. Okay, now we're going to take the derivative of r with respect to y, so this one. So that's just 2x cubed. 2x cubed, and then we have a z. The y, this part just goes to 1. And then we do have a y here, so that's going to be plus 42z. So look at that. Are they equal? Yes, they are. So we say that the vector field is conservative. So that means it has a potential function. And we're going to find this potential function. Okay, so now find potential function. We're going to represent the potential function with the lowercase f. The vector field is going to be with the uppercase f. So what a potential function will do is that if you take the derivative of the function, like let's say the derivative of the function with respect to x, that will give you the I component of the vector field. And if you take the derivative of this function with respect to y, then that will give you this component, the j component, and so on and so forth. So that is what we mean by having a potential function. So let's find this potential function. So in order to do that, in of x, y, z, because now we're using three variables instead of three components instead of two like we did in the last one. So that we're gonna have to integrate. You can actually choose which one of the components from the vector field you want to integrate, but I'm gonna choose this component, and since this is the I component, we're gonna integrate this with respect to x. But if you want to integrate this one, if you want to integrate this one, you'll integrate it with respect to y. So let's go ahead and choose. I like to choose this one, so let's choose this one first, and we're going to integrate that with respect to x. So let's go ahead and integrate with respect to x. So that is, we're going to take the component, and that would be 3x squared y z squared plus 72 xy squared minus 3. I'm just going to integrate that with respect to x. I'm just copying I'm just copying this down from the vector field, the I component, and integrating it with respect to x. So that's what I'm doing. So let's go ahead and continue. Okay, so now that we're going to integrate with respect to x, let's see what this equals to. So this equals to, let's see if I can write it here. Let's see, x cubed. You can just do this in your head. I'm pretty sure you know how to integrate by now. Yz squared plus, okay, that will be 72 divided by 2. What would that be? 36. 36x squared. And then we have the y squared minus 3x. So this is just basic integration from like your first semester of calculus. So I'm going to guess you should already know how to do this. Plus we have our constant. Our constant will be another function of y and z. So g of y and z, that will be our constant. So now we're going to take this, and we're going to take the derivative of this with respect to y. So let's take the derivative of our new that stuff with respect to y. That will be your part of your potential function. So let's take the derivative of x, y, z. This is the same as this. So let's take the derivative of that with respect to y. So let's do it. That will be x cubed z squared plus 36 times 2. That would be like 72, right? Let me make sure. 36 times 2, that's 72. 72 x squared y. The 3x will go to 0 because it's just a constant. It has no y in it. It's just a constant. And then plus g prime of y z. Okay, so let's look at this part. And then let's look at the rest of the derivative that we also have here. Would that be recognizable? Let's see. So x cubed z squared plus 72x squared y. X cubed z squared plus 72x squared y. And look where we have it. We have it right here. But wait. We also have this part. So the g prime of yz is equal to that one part. This one, the one that's under whatever that is, So the g prime of yz is going to be 21z squared. 21z squared. Okay. Okay, so now that we have g prime of yz, now that we figured out what that is, we're going to integrate g prime of yz, which is 21z squared, with respect to y, because we're still in the I component, and that it's going to give us 21z squared y. So now our new potential function is, let's see if I can write it here, is f of x, y, z. So it will be the same thing here. Actually, let me underline that in red so we can easily identify it. So this will be our potential function. So it will be that thing underlined in red. So let's copy it down. X cubed y z squared plus 36x squared y squared minus 3x plus. We need our new part of the function here that we just integrated from this, right? From g prime yz. So we are just going to put this new integrated part right here. So that will be 21z squared y. So that will be our updated potential function. So let's underline this in red. Yeah, that looks pretty bad. Let's underline, let's do that squiggly line in red to symbolize our new potential function. But we're not done. Oh yeah, I forgot. We're left with another constant. Another function of z. I mean, another function. But this function is with respect to z. So now we're going to have to find this. Find this. And the way we do that is, again, we're going to take the derivative with respect to z of our new potential function. We're going to take the derivative of this with respect to z. So again, f of x, y, z. So I'll just be taking the derivative of this thing underlined in red right here with respect to z. So that will be, let's see, 2x cubed yz plus, let's see, there's no z in right here, so that's just going to go to 0. And there's no z in with the 3, so that's just going to also go to 0. And let's see if there's a z. Yeah, there is a z in the 21. 21 times 2. But yeah, I believe that's 42. Z y plus h prime of z. Remember to also differentiate this part. So h prime of z. Okay, so let's see if that looks familiar to any of the components. So that is 2x cubed yz plus 42 zy. 2x cubed yz. I need 2x cubed yz here. So 2x cubed yz. So here's a 2x cubed yz, and this is a 42 zy, right? Does it match? 2x cubed yz plus 42 zy. Yeah, it does. It does match. Okay, so now we found our component, and this is our k component. But remember, we still have this part. Is there anything here that can equal to h prime of z? There is. It's just 0 because there's nothing there. So it's just 0. So we found out that h prime of z is 0. So there's really no need to integrate this because you're just not really going to get anything. So now we have our new updated potential function. So our potential function is f of x, y, z is equal to, just copy this thing down and just add, we're just going to add a constant. We're not going to add 0. We're just going to add a constant because it's just a constant, so it's not going to do anything. So that will be x cubed yz squared plus 36x squared y squared minus 3x plus 21z squared y plus a constant k. So this should be your potential function. So that will be your potential function. Let me make sure it's correct. So x cubed yz squared plus 36x squared y squared minus 3x plus 21z squared y plus k. Yeah, that looks about right. And this is what I'm talking about. So if we want to get our gradient from the potential function, so in order to check so in order to check, we're going to take our potential function, lowercase f, and take the derivatives with respect to x, y, and z, and that should give you big F of x, y, z, your gradient, which is going to be this. So let's confirm. So f of x, y, z is equal to, all right, we're going to take the derivative of this with respect to x, all of it, all of the function. So that is going to be, 3x squared yz. You can also try this also, plus 36 times 2. What's that? 36 times 2, that's 72. 72x y squared minus 3. Any x's here? No, they're not, so that's your I component. Plus, take the derivative with respect to y. That will be, take the derivative of the whole function with respect to y, and that will be x cubed z squared plus, again with your 72 x squared y, plus 21z squared, that's your j component, plus, all right, now the derivative of the whole function with respect to z, that's 2x cubed yz plus, actually there's nothing, no z here, no z there, so that is 0. Right here, 42 zy. And now check with this one, see if it's the same. So I'm gonna go ahead and check if it's the same, and it should be the same because it is a potential function, so it should be the same. So 3x y squared plus 72x squared y minus 3. Yeah, this looks good. X cubed z squared plus 72x squared y plus 21z squared. This also looks good. 21 x cubed yz plus 42 zy. Yeah, that was good too. So yeah, we did this right. Oops. So we did this right. So yeah, that's it.